Today we will take up the question, design a DFA that takes strings over the input alphabet, sigma is equal to AB, and contains only those strings that contain the substring BABA. Sigma is equal to AB, input alphabet is AB, and the string should contain BABA, that is the sequence given. So the transition diagram we will start making in the same manner. Q0, initial state, starts with an arrow, means it's an initial state. Then we will first initially put that string over here, B, Q1, A, Q2, B, Q3, A, Q4, and I've represented this Q4 with a double circle which shows that it is the final state. Now, whatever string is given which contains the substring, then we will write that substring in the same manner, B, A, B, A. Now, since it is the deterministic finite automata, so from every state we know that it should have transitions from all the given inputs. So what are our given inputs? The input alphabet is sigma is equal to AB. So it should have transition lines. Every state should have transition lines of A as well as B. तो हम देख रहे हैं कि B को तो हमने Q1 में डाला है, but Q0 से अब एक स्टेट जाना है. What is that? A. The transition for input A. So the transition for inputs A, for the best design of the DFA, we should put the transition to the nearest states, and since it should contain BABA substring, and before that BABA, you can have any number of A's before the substring BABA. So we will put it on to itself, that is the nearest state. Q0 on input A will be going to Q0 only. Now we consider for Q1. Q1, we are having one transition, that is of input state A. Now for input B, where we can put the transition from Q1 on input B. So we will consider again the nearest state B. The transition may go from here BABA, or the transition can go from here, that is BABA. So that shows that this B can be put onto the nearest state. Q1 on transition B will, on input B, will be going to the same state Q1. Now we'll consider for Q2. Q2 we are having the line, transition line for B. Now what about the transition line for A? Can we put it here? Then if we will be putting A over here, what it will take the sequence as? It can take the sequence as B, A, B, A, which will violate our sequence of BA, and it will be giving the sequence of AA, BA, which we do not want. So you cannot put A over here. It will be creating the sequence AA, BA, and may not have strings which contains BA, BA. So we cannot have this transition. So where we will put our A to the nearest state, we will find out if we can put A over here. Can we put A over here? What it will again do? AA, BA. So we cannot have A here also. So where we will be putting the A is to initial state Q0, where we can have any number of A's before having the substring BA, BA. So we can only put A over here, otherwise it violates the substring BA, BA. So now from Q2 A transition to Q0 and Q2 B transition to Q3. Now from Q3 we consider a transition is there to Q4. From Q3, what is the transition of B? Where we can put the B. So we now find that we cannot put B over onto itself. What it will make? ABBA sequence it will make. We cannot put here. What it will make? Again it will make BBBA. So we can put it over here where it will be BABA. So it is making the sequence from Q3 BABA. So the nearest state where we can put B transition from Q3 is to Q1. Now, since it is containing the substring BABA, it can have any sequence of A and B's in Q4 because after the substring BABA is followed, it can have any number of combinations of A and B. So we will be putting A and B over to the final state onto itself only, Q4 onto itself A, onto itself B. Fine. So this is the transition table which satisfies that it will always contain a substring BABA at least once. It can have more than once, but at least it will contain once the sequence of BABA. Although it goes from here BABA, if it comes from here BABA, like that it goes. So we will have at least one substring BABA by this transition diagram. Now we will make the phi tuple, that is M is equal to Q sigma del Q0 F. M sigma M is equal to phi tuple is M is equal to Q sigma del Q0 F, where Q is the total number of states, sigma is the input alphabet, del is the transition function, which is a mapping from Q cross sigma to Q, and Q0 is the initial state, F is the final set of final states. Where, how we will depict? Where Q is equal to all the states existing over here, Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4. Sigma is already given in our question, that is input alphabet is given, sigma is equal to A, B. Q0 is the initial state, final state is Q4. And del is given by the transition table, How we will make the transition table for this? First we will put all the states in the present state starting from Q0, since it is an initial state. An arrow will be before this Q0, initial state. Then Q0 is state here, Q1, Q2, Q3, Q4. Now we will write on input, sorry, there won't be a C over here. That was for the another question. There will be on input A and input B. Where will Q0 go? Q0 on input A is going to Q0. Q0 on input B is transiting to Q1. So you will write here Q1. Q1 on transition A is going to Q2. Q1 on transition B is going to Q1. That is how you make the transition table. Now, can make the transition table Q2 on A, Q0, Q2 on B, Q3, Q3 on transition A, Q4, and Q3 on transition B, Q1, and Q4 on transition A and B is going to Q4. Q4. Q4 is not visible over here, so I'm writing it again. Q4, Q4, Q4. Hope it is visible now. So we see that the DFA is designed for the string containing the substring BABA, which means that it should at least contain once this substring, and it should not take any other strings which does not contain BABA. So by checking the strings which does not contain BABA, you will find that they will not reach to the final state. If the string reaches the final state, then only that string is accepted by the DFA. So this was the DFA for strings containing the substring. We'll continue and find contains only those strings that ends with substring BA. So here, if we go for finding this substring BA, whenever you are making a DFA for the strings with substring and the strings that end with substring, only the final state will change. Even if you draw it all over again, you will have the same one for this. You will have the same one for this. So, here the Q4 cannot have the values of A and B onto itself. Why? Because we want that the string should end with BA. Whatever is the string, ending should be with BA. So when it comes from here, BA, it should end over here, should not have any other sequence of A and B over here. So where we can put now A, where we can put the A, either to this place we have to find BA, it will be, or we can put it over here BA, again, B again, it will violate. You can put A over here, no. So you can put A only to Q0. Because when you are putting it over here, it violates. What will happen? जब आप यहाँ पे A डालेंगे तो क्या sequence बन जाएगा? B A. It will make the sequence B A and it will end with B A. That we don't want. So we cannot put over here. If we put A over here, what sequence it will make? B A. So some A is coming extra in between. If we put A over here, again it will make A. So we have to put A to Q0. And where will we be putting the B? Here, can we put B over here? No, because the sequence should not end with B, it should end with BA. So we will try to the nearest one. Can we put B over here? BA. It will be going to the final state only through this A. So we can have BA. So we see that we can put it to the nearest state Q4 to Q3. B we can put. What sequence it will make? BA. And how your transition table will change? Q4 only will change. Q4 on input A is now going to Q0. On input A is going to Q0 and Q4 on input B is going to Q3. This is going to Q3. is going to Q3. So we are having the del is given by this transition table. We have changed it for strings that ends with BA. Now what will change over here? Nothing. Only del is changed, that the transition table is changed. Otherwise, M is equal to Q sigma del Q0F is the same. Only del has changed. So we see here that we have a transition diagram now for strings that end with BABA by only changing the final transitions, which cannot be onto itself. Otherwise, it can make any sequence of A and B after BABA. That cannot be allowed because the string has to end with BABA. So we will be properly ending the string with BA only, and so we cannot put BA onto itself in Q4. So that way, only our transition table has changed and our phi tuple remains the same. So this is the DFA for strings that contain BABA and strings that end with BABA. Thank you.